Hi everyone. So today we're going to look at solving equations of the type mod ax plus b equals mod cx plus d. Now essentially we can solve it via a few methods. We can actually graph it out and see the intersection, but of course that will require the use of graph paper and accurate graphing. Now the more common way of us solving this kind of equation of two modulus is by algebraic method. All right, so today I'm going to show you two different methods on solving such equation. The first method, what we will do is we call it the plus plus or plus minus and plus minus method. And what we will essentially do is that we're going to equate both the modulus as if they were positive linear equation. So that will be our first step. So therefore I'm going to say x minus 5 is equals to x plus 1. All right, so this is kind of the plus plus. Now the plus minus would be that one of the linear part is going to be positive, for example x minus 5, and the other linear part is going to be a negative, so we're going to have minus x minus 1. All right, so from here we're just going to solve for x. So in this case we can't really solve this, so this is NA. Because x and x will cancel each other, so that's gone. Whereas on this side we can actually solve it. So we have 2x equals to 4 and x equals to 2. Now we have to always check our answer to make sure that it is correct. So we're going to check mod 2 minus 5, which is equals to positive 3. We're going to check mod 2 plus 1, which is also 3. So this is in fact true. All right, so this is the method, the first method, the plus plus and plus minus method. All right. Now, the second method we're going to go through is using squaring of both sides. So we're going to treat it kind of like a quadratic equation, and we'll attempt to try to solve it. All right. Again, after we solve, we have to check if there is any false answers. We have to always check our answers. All right. So we're going to square both sides. So this rule applies. So mod P equals to mod Q would therefore equals to P squared equals to Q squared. So this is kind of the rule we will apply here. All right, so x minus 5 squared therefore equals to x plus 1 squared. So we'll go ahead and expand this expansion. So x squared minus 10x plus 25 equals to x squared plus 2x plus 1. So the common here is x squared. We will just cancel that out. Simplify that. So we will have 12x equals to 24. Therefore, x equals to 2. And just like before, we know that this is going to be true. All right. So these are the two methods you can try, the plus plus and plus minus, or square both sides, if there is a modulus equals to a modulus. Yeah, and this both has to be linear type. All right, now let's look at example 2. It's a bit more complicated. Now, you may think that, okay, we can also apply the square both sides, but unfortunately you can't do that. For such an equation, you can actually only use the plus plus and plus minus method. All right, so let's go ahead and try it. So what I'm going to do is I'm going to try to isolate one of the linear modulus. So probably x plus 4, I'll isolate it on the left. Right, so I'm going to say x plus 4 is equals to 11 minus mod x minus 5. Notice that I don't remove my modulus. Yeah, I still keep it. All right, now here we're going to split. So I'm going to have the plus version and the plus plus version and the plus minus version here. All right, so the plus plus version would basically means x plus 4 equals to 11 minus mod x minus 5. Essentially nothing changed, just remove the mod on the left side. Now this is the plus plus version. Now let's do the plus minus version. So this is going to be x plus 4 equals to minus 11 plus mod x minus 5. Okay, so this is the plus minus version. So the minus version essentially I multiply negative to the right side. Okay. So what's interesting here is that we will actually have to further split the things up. So we try to isolate the modulus first, okay? So maybe we do it on the left side, yeah? So I'll bring the modulus to the left. So x minus 5 mod equals to 11 minus x minus 4. So mod x minus 5 is equals to minus x plus 7. Okay. Now, from here, I will split further. Okay. So I'll split it up to the plus and plus minus version. All right. So let's look at that. This will be x minus 5 equals to minus x plus 7. And we have x minus 5 equals to x minus 7. We know we can't solve this because both have x on the left and right side. You'll cancel out, so we can't solve that. We can solve the one on the left side. So 2x equals to, let's see, 7 plus 5. That is 12, right? And x equals to 6. All right, we have to, of course, always check the answer. So let's sub it in. So 6 plus 4 mod plus 6 minus 5 is in fact 11. Yes, that's true. Okay, so this is correct. All right, so that's done on the left. Now let's solve the one on the right. We again have to isolate mod x minus 5. For mod x minus 5 essentially is equals to x plus 15. Okay. Now from here we have to split to double check the various possible scenarios. So the plus version will be x minus 5 equals to x plus 15. We know we can't solve this part because x and x will cancel out and there's no solution. Now the plus minus version, so x minus 5 equals to minus x minus 15. So 2x equals to minus 10. So x equals to minus 5. All right, let's double check that. So mod of minus 5 plus 4 plus minus 5 minus 5. Okay, let me do it mentally. So that is minus 1, so 1. So it's 11 as well. Yep, so it is true. All right, so all in all, we have two answers. So maybe we put here, our answers is going to be, oops. So our answers, basically it's x equals to minus 5 and x equals to 6. All right, so that's our final answer. All right, so I hope this is clear on how you solve modulus equation. All right, there are various methods to do it. So it's really up to you what you want to choose, and depends on context. Sometimes you can only choose a plus and plus minus version. All right, so my recommendation is just always look and try whichever method you're comfortable with. If it doesn't work out, always rely the plus and plus minus version. That would be the best option. All right, so I hope this is all clear, and I'll see you in the next video. Cheers.